So 4.3, permutations with some identical items. Okay, if we order the letters in the word doll, there's an issue. The word doll has two L's in it, and those L's are obviously identical. Okay, we can't tell two L's apart. So therefore, we must take into account the orderings that do not repeat. Okay, so again, we're dealing with permutations. We saw this in 4.2 and 4.1 where we have like NPR, right? We have N number of items and we're ordering R number of them. So N, and then the P can be order R, so order. Okay, and we're dealing with factorials. So if we're ordering all of them, NPN is actually just n factorial because we're ordering all of them. So let's take a look at example 1. List all ordered combinations of the following two words. So if we have the word ACE, we have ACE, we also have AEC, and we have CAE and CEA, and then we have EAC and ECA. So we have the word ACE, which is 3 letters, all of them are unique, and we have 6 different ways that we can order them. So when a question asks you how many words can you spell, it doesn't mean actual words that like make sense, like SIA, like CEA. We're going to consider that a word for the scope of like this course where it's a unique spelling. Okay, now B, I. So essentially we have like EYE, and this would be E1 and E2. But if you think about if we spell it with EYE and we put the second E first and then the first E like as the last letter, these are actually duplicates, so we don't include that one. Okay, what about EEY? Well, E1, E2Y, and E2, E1Y is actually the same word. So again, we don't include that one. And then we have YEE, E1, E2, and then YEE. And again, these two are the same word, so we don't include it. So how many ways can we spell the word I or spell a word with the letters EYE? 3 ways. Okay. So when dealing with permutations of n items that include A identical items of one type, B identical items of another type, and so on, so like A, B, C, okay, you can use this formula here. So what we would do is we would do the n factorial on top, which is every single possible way that we can write that, say, for example, word. And then we're going to divide out A factorial, B factorial, C factorial for all of the duplicates. Okay, so here's the difference. So if we have 3 different letters, which we saw with the CEA, right? So the ACE example, there are 3 factorial ways of ordering. Well, we got 6 ways. If we wanted to calculate it, we'd simply just do 3 factorial, which is 3 times 2 times 1. Now, on the other hand, if we have 3 letters with 1 repeating 2 times, and this is the EYE example, when there is a duplicate, we must divide the factorial by the number of duplicating items. Okay, the word I has 3 letters. So 3 factorial is going to be the numerator. And the letter E repeats 2 times. So 2 factorial is going to be the denominator. So we have 3 factorial over 2 factorial ways of ordering the letters of the word I. And this is actually by the factorial of the number of duplicated items. So if we actually redid the examples in number 1, ACE, we're going to get 3 factorial, which is just 6. EYE, we're going to get 3 factorial, but there's 2 E's, so we're going to divide out 2 factorial. So we're going to get 3. So this is going to be 6 ways to order them and 3 ways to order them. Example 3. Frank is laying tiles on his floor. He has 4 red tiles, 6 pink tiles, and 3 green tiles. How many patterns can Frank make? Okay, so the 4 red tiles, we cannot distinguish between them. Okay, they're identical. That's what we're assuming. Okay, the 6 pink tiles, again, identical, and the 3 green tiles, again, identical. So the total number of tiles that we're dealing with, we just add up 4 plus 6 plus 3, which is 13. So the total number of ways that Frank can lay the 13 tiles, if they're in order, is 13 factorial. But the red tiles, we have 4 of them, so we're going to divide by 4 factorial. We have 6 pink tiles, so we're going to divide by 6 factorial. And we have 3 green tiles, so we're going to divide by 3 factorial. Okay, if we put this into our calculators, we're going to get a massive number. I'm going to do this in 2 steps, but I want you guys to be able to do it in 1 step. 6,227,020,800. And then if we do 4 factorial times 6 factorial times 3 factorial, all in one shot, should fit in your calculator, 103,680. And then if we divide out, we are going to get 60,060 patterns. Example 4. How many permutations are there of the letters in the word Mississauga? So when I get a question like this, I take this word Mississauga and I spell it out, but I actually stack the letters. So MISSISSAGUA. And why I do that is because I can clearly see that there are 2 I's, there are 4 S's, and there are 2 A's. Okay, so if we count the letters in the word Mississauga, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we're going to get 11 factorial in the numerator. And now we just have to divide out the duplicates. So we're going to divide out 2 factorial, 4 factorial, and 2 factorial. I'll do this again as a 2-stepper, but a lot of times I won't do this. Okay, 2 factorial times 4 factorial times 2 factorial. I get divided by 96. And I get 415,800. Okay, there's that many ways to spell the word Mississauga, or spell words with the letters from the word Mississauga.